Hi, Assalamualaikum and a very good morning. So now we're going to do some tutorial discussion for chapter 10 and we're going to focus on the subtopic of 10.4 which is the preparation of carboxylic acid and 10.5 which is the chemical properties of the carboxylic acid. So we're going to do tutorial question 5, 6, 7, 8 and 9 respectively. So without any further ado, let us start. So for tutorial question 5, we have to identify compound in the letter A until I in the following reaction. So let's say if we have 1, 2, 3, 4, which is 2-chlorobutanol. So when we react the 2-chlorobutanol with KMnO4, at first it is in alkaline condition, at high temperature and at acidic condition. So basically this situation here is the same as KMnO4 happens at high temperature at acidic condition. So initially they are in alkaline, but at step number 2 it's gonna be acid. So overall it's gonna be an acidic condition. So aldehyde gonna undergo oxidation with a strong oxidation agent in order to produce a carboxylic acid. So what you're gonna get is the C double bond O H here gonna become C double bond OH. Okay, so you can write it in terms of this way, or you can also write it in terms of the skeleton structure. Okay, and next we have the CH3 CH2 CH2OH, which is a propanol. So the propanol will undergo oxidation with a strong oxidizing agent, which is dipotassium chromate, in order to produce a carboxylic acid as well. So it's gonna produce a propanoic acid, which is CH3, CH2, CH2OH now is changed into C double bond O, OH here. Okay. Next for C, we have a structure C here, react with sodium hydroxide in order to produce a carboxylate ion with a sodium metal attached to it. So essentially, it's basically a carboxylate acid and it has a structure of CH3, CH2, COOH. Okay, so this H here gonna be replaced by sodium, and H and OH gonna be used to produce the water here. Okay, so the originally is exists as a propanoic acid. Okay, now for the structure D here, we have a methanol and it reacts with a structure D in the condition of the sulfuric acid catalyst at high temperature, and then it's going to produce the structure here. Okay, so when you see oxygen and oxygen back to back, okay, secara bersebelahan in the middle of the carbon chain, so you know that it is an ester. Okay, so the structure going to be CH3, CH2, C double bond O, O, CH3. Okay, so you know that this structure here refers to an ester functional group. Okay, the class of the compound will be ester. Okay, so you know that ester will be formed via a reaction of alcohol plus carboxylic acid. So here you have your alcohol. So the other side here gonna be a carboxylic acid. Okay, because this side here come from an alcohol. Okay, the one circle here come from an alcohol. This box here gonna come from a carboxylic acid. So you know that your carboxylic acid gonna be CH3, CH2, C double bond O, OH. Okay, so it's gonna be written as CH3, CH2, COOH. Okay, and now for E, we have our carboxylic acid here. So it's gonna be reacted with a reagent E in order to substitute the C double bond OH here, and now it will change into Cl. Okay, so gonna become like this, and the byproduct here gonna be hydrochloric acid and sulfur dioxide. Okay, and in this case, you might be tempted. Okay, you might write it as PCl3, or you might also write it as PCl5. Okay, so for this one, both of these answers are incorrect. Okay, you should only write as SOCl2. Okay, why is that? Because it gives you the byproduct here. where the SOCl2, which is the thionyl sulfide, thionyl chloride, sorry, thionyl chloride will react with the carboxylic acid in order to produce C double bond OCl, and the byproduct here going to be hydrochloric acid and sulfur dioxide. These two here can form COCl, but the byproduct going to be different. So specifically for this reaction, you have to use SOCl2. Now moving on to the next equation, which is F CH3CH2COOH, and then it will undergo reduction with lithium aluminum hydride in the presence of ether followed by hydrolysis. So carboxylic acid gonna be reduced into so here gonna be a SOCl2 in the presence of pyridine, okay? And here carboxylic acid gonna be reduced into alcohol. Alright, so C double bond O, OH here. So oxygen gonna remove and change it with 2 hydrogen. Okay, the other will just follow up. Okay, so these are the structure here. And now for G, you have your carboxylic acid, and then it reacts with the excess ammonia NH3. So it will have two steps. Usually, you will undergo straight away into H actually. Okay, but then it gives you in the middle here. So what happened in the middle is essentially CH3 C double bond O. It will become O minus here because this hydrogen gonna be taken up by the nucleophile of ammonia. So it's gonna be NH4 plus. Okay, so here gonna be the structure G. Okay, but the usual way that you learn, which is the structure H here, what gonna happen is that the ammonia gonna enter, which is gonna attack the nucleophile, and then the double bond gonna become OH, and then the water OH here gonna be removed out as the byproduct of water. Okay, so the NH2 gonna be attached here, and then it will become COH. Okay, so let's draw nicely. Okay, so for G, you can draw it in terms of like this, which is C double bond O minus and H4 plus because the ammonia gonna take the hydrogen. And for H, the ammonia gonna attack the nucleophile, and then this gonna take hydrogen, and then the OH group here gonna leave as a byproduct of water. Okay, so this is the structure of G and H. And next for H, okay, this one is quite easy. CH3, CH2, C double bond O, OH. So OH here going to be replaced by Cl. Okay, similar to what you have learned in E. Okay, so you're going to get this structure here. Okay, so you can also make the structure nicer to be as C double bond O, Cl. Okay, and then CH3, CH2. Okay, so make sure to write it nicely. Okay, and then the byproduct here you can also write it as sulfur dioxide as well as hydrochloric acid. Okay, and then for the next one, we have your carboxylic acid. So your carboxylic acid here gonna react with a metal, which is an alkali metal from group 2. So it's gonna be Mg2 plus. So usually the H here gonna be replaced by a magnesium metal. Okay, so magnesium 2 plus, and then you cannot leave it like this. You need to ensure that the charge is balanced. So Mg2 plus, this one is minus, right? So you're gonna add up 2 molecule here. Okay, so at the below here, all of this carboxylate ion gonna be 2 of it. Okay, because it's gonna become 2 minus and 2 plus. So therefore it's gonna be neutral. Okay, with a charge of 0. And the byproduct of this reaction going to be hydrogen gas as well. Okay, so you can include SO2 here and HCl here as well. Okay, so that's for question number 5. For question number 6, based on the reaction scheme below, we have to draw the structural formulae for the compound M. Okay, so we are given two carboxylic acid 1, carboxylic acid 2. So it's basically is the same thing. Okay, here is CH2. Okay, so for compound M, it's basically a reaction between two carboxylic acid. So what going to produce here is anhydride. Okay, so you can also redraw the structure again, and on this side you can make it as CH2 C double bond O OH. Okay, so when two of the same carboxylic acid are reacted together, hydrogen and OH going to be removed in order to produce water. Okay, and the C and the oxygen here gonna be connected together in order to form an anhydride. Okay, so what you're gonna draw is this kind of structure, which is this structure here. C will attach with the oxygen of the next carboxylic acid. Okay, and then you just redraw it as normal, C double bond O CH2, and then with a cyclopentane here. So this is known as the anhydride formation. Okay, so this is something that you have learned in your lecture. And then next we need to give the reagent R. Okay, so we have your carboxylic acid here. Okay, so we only focus on one substance because it's still the same. So let's say if you have carboxylic acid, and then what you're going to produce here is an ester. Okay, so you know that the carboxylic acid need to be reacted with alcohol. So you know that the reagent are going to be an alcohol. Okay, so what kind of alcohol is that? So the clue is to look at here. Okay, so you know that it's gonna be CH2 C double bond O, and then the OH gonna be removed. So the structure here gonna come from this side here. So the alcohol that you will be using is CH3 CH2 OH, which is an ethanol. Okay, so you know that this is your reagent. At the same time, for an esterification to happen, untuk proses esterifikasi untuk berlaku, we need to have the concentrated H2SO4, which acting as a acidic catalyst. Okay, so we need to write both of these reagent as the answer here. So you can write CH3 CH2OH as well as the concentrated H2SO4. Alright. Now for tutorial question 7, we have to show how the propanoic acid may be converted to each of the following compound. So propanoic acid will have 3 carbon, which is 1, 2, and 3, and then a carboxylic ion here. So this is propanoic acid, which has 3 carbon, and then I need to produce 1, 2, 3, 4 carbon, which is a butanoic acid. Okay, so it's going to be extra 1 here, 1, 2, 3, 4 OH, which is 4 carbon. Okay, so you know that I need to add the 1 carbon chain here. Okay, and as you know, the addition of 1 carbon, we can use cyanide, or which is the nitrile compound, or using a Grignard reagent. Okay, and usually for a carboxylic acid, we will be dealing with a cyanide compound or the nitrile compound here. Okay, so let us do the reaction scheme one by one. Okay, so from a carboxylic acid, what I'm going to do first, okay, so here's my carboxylic acid. What I'm going to do is I'm going to reduce it first so that it become an alcohol. Okay, so I'm going to reduce it using a lithium aluminum hydride followed by hydrolysis. So the number 1 and number 2 here is important. Okay, do not skip number 1 and number 2 because it needs to be stepwise. Lithium aluminum hydride followed by hydrolysis. So the numbering here is important. And then the carboxylic acid going to be reduced into a primary alcohol. So from propanoic acid, it will become one propanol. Okay, and this propanol here is not reactive. So what we're going to do is we're going to replace the OH into halogen. So that it will become haloalkene. Okay, so let's see if I'm using PCl3, the OH here going to be replaced by Cl. Okay, so from Cl here, I will undergo nucleophilic substitution reaction where Cl, I'm going to change it with cyanide. Okay, so why I need to use cyanide? Because I need to add one carbon chain in order to form 4 carbon. Okay, so that's the idea. So for the cyanide, the condition is we need to use an ACN in ethanol, or you can use KCN. Okay, so you have learned about this in chapter 7 as well as in this chapter, which is the carboxylic acid. So the example is in the lecture note. And then what you're going to do is that the Cl going to replace the Cn into here, and then the Cn will undergo hydrolysis in order to form the carboxylic acid. Okay, so it will undergo hydrolysis, acidic hydrolysis, which is H2O, H plus, and this is going to produce the product that we wanted, which is 1, 2, 3, 4, butanoic acid. So the similar to what we wanted to synthesis, apa yang kita nak hasilkan. So we're going to do it step by step as mentioned here. Okay, now we're going to look into question 7D, which is we need to prepare 2 propanol. So first we have a propanoic acid, which is the same as before, but now I want to produce 2 propanol. So my OH is in the middle. Okay, so what I'm going to do here, I can undergo reduction first. So if I were to undergo reduction, I will get 1, 2, 3 OH here. Okay, so when I undergo reduction, I will get a primary propanol, a primary alcohol, or 1 propanol. Okay, but I want it to be 2 propanol. So what I can do is that I will undergo dehydration, where I can remove OH and I can remove hydrogen here. So I will become an alkene. Okay, next I will undergo it. I will react it again with water. Okay, which is H2O and H plus, and then it will undergo Markov-Nikov rule, so that the hydrogen going to enter here and the hydroxide going to enter here. Okay, so that's my idea. So let's draw it nicely one by one. So I have a propanoic acid here, and then I will undergo reduction into 1 propanol, and the 1 propanol can undergo dehydration with concentrated H2SO4 in order to produce an alkene here. Okay, so this is an alkene. And now we're going to react that again with water as well as the acid. So what will happen here is that the hydrogen, okay, so the hydrogen here gonna attach to the carbon that has more hydrogen attached to it. Okay, so the OH gonna attach here. Okay, and this gonna follows the Markov-Nikov rule. Okay, where the hydrogen going to attach to the carbon which has more hydrogen attached to it. Okay, and this going to produce my secondary alcohol, and in this case it's going to be 2-propanol. And this is how I prepare propanoic acid to 2-propanol. Okay, so for tutorial question 8, an organic compound P has a molecular formula of C3H6O, and it reacts with the Cr2O7 to minus H plus, which is a chromic acid, in order to form Q. Q react with ethanol to give sweet smelling liquid R. The reaction is catalyzed by concentrated sulfuric acid. So if you were to read it like this, you will find it very difficult in order to digest the information. So what we're going to do is we need to come out with an idea first in order to understand the situation here. Okay, and for the equation 1, we have to identify P, Q, and R, and we have to write the equation for the reaction involved. So as I mentioned, we have to come up with an idea first. So an organic compound P, okay, has the molecular formula of C3H6O, okay, and it reacts with a Cr2O7 2 minus dengan H plus, which is a chromic acid, in order to form Q. And then Q reacts with ethanol. So ethanol will have a molecular formula of CH3, CH2OH, or you can put it as C2H5OH. Okay, so Q gonna react with C2H5OH in order to produce sweet smelling liquid R. And the reaction is catalyzed by concentrated sulfuric acid. Okay, and from your knowledge, you will know that the sweet smelling liquid R here gonna be an ester. Okay, and ester gonna be produced from the reaction of alcohol and carboxylic acid. Okay, so that's the idea that you have known. And the carboxylic acid can come from an alcohol or an aldehyde. Okay, where it undergo oxidation to form carboxylic acid. So for the P here, as you look into the structure, you're going to have C3H6O. So if you were to draw 1, 2, and 3, and let's say if I make an aldehyde here, it's going to have a consistent molecular formula, which is 1, 2, and 3. And then hydrogen going to be 6, and oxygen going to be 1. However, if uh, I'm doing an alcohol here, my structure here gonna be not consistent because I'm gonna get 8 hydrogen. Okay, so here only got 6. So you know that my structure here confirm need to be an aldehyde because of the molecular formula. Okay, so my aldehyde will undergo oxidation with a strong oxidizing agent, which is the chromic acid, in order to produce a carboxylic acid. So you know that the structure here going to be CH3, CH2, C double bond OH. So when it undergo oxidation, it's going to be CH3, CH2, C double bond OH. Okay, so you can put it as C2H5COOH also okay because you will combine the two things together. Okay, and this carboxylic acid gonna react with alcohol in order to produce an ester. So from the alcohol part, from the carboxylic acid part, we're gonna remove OH, and from the alcohol part, we're gonna remove hydrogen. So we're gonna combine that together. So we're gonna get C2H5, or because it comes from the oxygen, C2H5. Okay, or you can also expand it again to become CH3, CH2, or CH2, CH3. Okay, so both answers are accepted. Okay, so you can put it as CH3, CH2, C double bond O here, and with a dash here because it comes from this type. Okay, and same goes to this one. Okay, so it's gonna become an ester group here, and then it's gonna follow up with CH2 and CH3. Okay, so that's one is for ester. So we already come up with an idea plan here, and we also have identify P, Q, and R. Okay, however, the question asks you to write the equation for the reaction involved. Okay, here might not be quite right for an equation. It may be sound as a reaction scheme. So to be safe, I would suggest you to write every single step individually. Okay, so the idea here is important, but in order to get a full mark, you need to write the equation again. So let's say if you have your aldehyde here, which is PC3H6O, you can react that with a chromic acid, which is H plus, in order to produce a carboxylic acid Q. So this is the first equation here. Okay, and you can also draw it in terms of like this, doesn't matter. Okay, okay, you can, if you want to draw it this way here, is also okay. And then for number 2, the carboxylic acid, which is the Q here, gonna react with the alcohol C2H5OH, and this gonna remove the OH and H here in order to produce an ester. And this happen with the presence of concentrated H2SO4 as a catalyst, and this gonna produce our ester here. Okay, so equation 1, and this is the equation 2. Okay, and for the next part, we have to suggest the suitable Grignard reagent that can be used in order to produce Q. So Q is C2H5COOH. So, or you can write it as CH3CH2COOH. So we have to suggest the Grignard reagent. So Grignard reagent, we need to use MgBr. So what I can do is that I will maintain the part here, CH3, CH2, and I'm going to make it as MgBr, or I can also use it as MgCl. Okay, because you know that when the Grignard reagent, for example, this Grignard reagent, react with methanol, okay, what they're going to produce is they're going to be an increase in the carbon chain here, and then it's going to produce a primary alcohol, and from the primary alcohol it can oxidize to produce a carboxylic acid. Okay, so you can use the structure here as the Grignard reagent. Okay, so the suitable Grignard reagent can be CH3CH2 MgBr or CH3CH2 MgCl. Okay, so for tutorial question 9, we have to explain why methanoic acid give positive result with tolerance test and acidified potassium permanganate, but ethanoic acid does not. So as you know that the methanoic acid essentially has a structure of C double bond O, OH with a hydrogen. So it only have one carbon. So this is the structure of the methanoic acid. So the methanoic acid will have an aldehyde properties. At the same time, the methanoic acid going to have its acidic properties, where it comes from the carboxylate ion. Okay, so the methanoic acid going to give positive result because it have a functional group of aldehyde, where the tolerance test going to detect the presence of aldehyde, and then the aldehyde can be oxidized via a strong oxidizing agent, which is the potassium permanganate. Okay, so what we're going to do is we can give an explanation here. So the methanoic acid shows the reducing properties because of the presence of the C double bond OH, which functional group, which refers to an aldehyde. It reduces tolerance reagent. At the same time, the methanoic acid will have the acidic properties because of the carboxylate functional group, where it reacts with bases in order to form salt. So, methanoic acid, you can give an example here, can react with a sodium metal in order to produce carboxylate ion with a Na plus here. So this is going to form a salt. Okay, so when there is a reaction, okay, the byproduct here going to be hydrogen gas. So when there is a reaction of an acid with a base metal, so it's going to produce a salt. So you know that it is acting as an acid. Okay, so methanoic acid is both an acid and also an aldehyde. Okay, and now we're going to show the reaction of the methanoic acid with the KMnO4. So for the methanoic acid, it can react with a strong oxidizing agent, which is KMnO4, at the acidic properties at high temperature, and this is going to produce carbon dioxide and H2O because it's going to break apart the bond. Okay, and this going to produce a byproduct of manganese dioxide. So from KMnO4, it's going to produce MnO2, which refers to the formation of the brown precipitate. And now we're going to react the methanoic acid with the tolerance reagent. So the tolerance reagent going to have AgNH3 bracket 2 and a plus charge here. And this must happen at the basic condition. Okay, so what gonna happen here is that it gonna produce carbon dioxide as well as water, but now it gonna precipitate down the silver. Okay, so this is a silver mirror test, and the observation is that you can see a silver color on the wall of the test tube. Okay, and this clearly shows that the methanoic acid can be oxidized, and the methanoic acid can be reduced, can be reacted with tolerance reagent, which shows that it is an aldehyde. Okay, but this situation is not happen for the ethanoic acid, because ethanoic acid only have the acidic properties. So you can say that the ethanoic acid may only show acidic properties because it does not have the aldehyde functional group as in the methanoic acid. Okay, but it only have the carboxylate functional group. So that is why the ethanoic acid will not undergo oxidation. Okay, will not undergo oxidation. At the same time, it will not give a positive result towards the tolerance reagent. Okay, alright. So I think that's all for today's video. See you again some other time. Bye.